Good morning. How are you?
How are you? Sorry.
Yeah, that's all right. I think we're all just used to that now all the time, huh?
Yeah.
We're just
Pretty
always
much.
muted, talking while being muted. How's everything going?
Good. I was just doing some physics homework, but
Oh, oh
yeah,
gosh.
tough.
How's that going?
It's pretty tough. Physics is no joke.
Yeah. Ugh. Yeah, yeah. I can't even, I don't even know how y'all do that stuff. That's way beyond my brain power for sure. Um, So, yeah, everything, oh my gosh, everything's been so hectic, so hectic. And so I haven't gotten my textbook, which is so annoying. And I have to like get access granted to go on to campus, and I haven't done, well, I've requested it. I just haven't gotten that yet. So I need to get my textbook because I've realized now that I used to just kind of teach right out of the textbook because
Okay.
mostly like I don't have slides for
Mhm.
all these chapters. You know, when I was face to face, it's not like I just showed slides in this class.
Yeah.
And so now I've realized like, well, wait a minute, now what do I do? Because I don't have, I don't have that stuff. For you all, and it's just a weird kind of scenario. So, however, I put together just a few little PowerPoint slides. It's really not much of anything, kind of like how chapter 4 was, because it's mostly calculations and stuff. It's not anything that we really need to like look at slides for. So I put them together. I just now put them up right away. And so let's see, what is she telling me? Oh, you have the, yeah, okay. Yeah, that would be awesome. Cynthia,
I
if you
could
could,
send it to you if you want. I mean, that
yeah, I mean,
it's kind of
I'm gonna go
hard
in
because
anyways and get my book, just because I know like I've written a lot of notes in it and I have all these things highlighted. Like I just use that as my, just it's my baby for statistics. And so, but yeah, the PDF would be awesome because, I mean, and I thought about buying it last night and I was like, no, it's the principle of it. I have it. But now that I think about it, if I had the PDF, because then I could take images and show you all and I could put those in slides. Obviously I could do it for my textbook too, but I'd be taking like pictures with my camera and then uploading it. So that just might make my life a little bit easier to be able to just take those images straight from the PDF. So,
I'm trying to see if I can put it in this chat or if I send it, like,
oh,
I don't know exact. I'm trying to see
how to do that?
how I can get it to
You
you
might
other than
have
an
to,
email.
yeah, you might have to email it to me if it's probably very large.
Yeah,
Um,
let me see.
and
Um, do I send it to your school email? Is
You know,
that what you want me?
usually we don't have a limit on it, but just in case, here's my personal email. And that one I know wouldn't, wouldn't have a limit. So it's just Shannon_Vias@live.com.
Okay, I'm
Um,
gonna try to send it
just
to you
to
right
see.
now.
Okay, that would be awesome. Thank you.
Uh-huh.
So I looked over the exams. The exams look well. They look good. I hope they were okay with you. I noticed some people might have, had a lower score. Maybe they weren't real happy with the lower score, but I also noticed that those very same people only took it once. They didn't take the second attempt. And so I don't know if that was, oh, oops. Uh-oh, where'd y'all go? I don't know what that is. Uh, are y'all still there?
Wait, yes.
You are? What happened? Where did you go? What is this? I accidentally pushed this stupid little button, and it took me away from you all. Okay. Sorry, I don't know what happened. Anyways, so I'll go back and open that again, just in case if anybody wants to take another, stab at it, just to try and raise that score. But I don't want to talk too much about the exam either. But how was it for you guys? Did you feel like it was okay?
Um, yeah, overall it was okay. I did end up like getting for the second attempt, I ended up getting like 3 questions wrong. And 2 of them were in regards to the idea of like inferential statistics. I'm guessing I still don't understand the concept of inferential statistics based on why I got them wrong. I mean, I know like based on also when I looked at through the book and when I I was also like even before we took the test, like I got an idea what it was, but then when it gave you like different answer choices, like none of them seemed like similar
To be,
to what I guess you taught us. I mean, I know
Okay.
it is, but it's like I didn't know how to like um reference it or maybe translate it to those kind of answer choices.
Okay. Yeah, I can think of a few questions. Obviously, I can't think of them word for word. And then the hardest part, I can't think of every answer choice.
Yeah, of course.
So I can go in and look at it, and and I'll look at yours and I'll see which answers you put, and then I'll email you. Is that okay?
Yes.
Okay, just to try and tell you, oh, this is what happened, or this was the answer, and
Yeah.
kind of, okay. And so of course, if anybody else wants that assistance, because I know sometimes, like, if we did a test face to face and I passed it back to you guys, you would be able to come up or come into my office and say, hey, why did I miss this one? So we can do that. Okay, so if you can remember maybe one that just really bugged you and you don't understand why or what the answer was, email me and I can go in and look at those questions. Okay, and I can see what you put and all of that stuff. So I'll do that. Okay, Natalia, I'll do that. When I get off here, we get out about 12, and then I have a class. So it'll be a little bit this afternoon, but I'll do it. Okay. Of course, please, if I don't, please email me and remind me. Okay. Yeah, I'll try it really hard and remember, I promise you. But sometimes, things happen. So let's just start going over chapter 5. And here's the other thing that I wanted to mention about chapter 5 is I don't necessarily like the way this author does chapter 5 and then goes to chapter 6 and then chapter 7. In my head, chapter 5 and chapter 7 should be discussed together. So I always bump chapter 6. Okay, I'm not sure if I did that on the syllabus or not. I probably did. That sounds like something I would do. If I didn't, I'm doing it now. Okay, so we're going to bump chapter 6. And we're going to talk about chapter 5 and chapter 7. And in my mind, and I believe that it helps you all a little bit better too, to almost talk about them, chapter 5 and chapter 7 concurrently or together, because if I start off just with chapter 5, sometimes we're left like, why are we doing this? And then it takes forever to get to chapter 7, which explains the why. And I just think sometimes that leaves people hanging for too long. I really don't understand why he would put chapter 6 in the middle of it, which is regression, and it just doesn't even make sense with right now. So that's just so you know. In my head, that's why I'll be doing this, okay? It's not meant to try and confuse you or skip around or do anything like that. It's the contrary. I think that it makes more sense for them to go together, okay? So let me pull up. Oh, okay, not there. Let me pull up my Blackboard and one of our statistics classes to the documents so I can get the slides. Oh, and I hope y'all are doing okay with the, I mean, obviously today will be my next time of trying to upload the slides. That, yeah, it became a major problem. But hopefully the YouTube thing was working. Are you guys okay? All right. I'm like, yes, do it. Okay. All right. So as you can tell, I really did not do very much on this at all because it's so much more than just, you know, words on a slide. And so it's more about showing you and discussing it and talking about it. So let's just go over a little bit. Mostly this chapter 5 will start off talking about, he says, he titles it Other Descriptive Statistics, and it's where we get z-scores. He goes on and talks about like effect size and box plots and things like that. We are largely going to focus on z-scores. I will push effect size to when we're talking about t-tests. Okay, so I'm not skipping effect size, I'm just bumping that one till later. And then we won't talk about box plots and things like that. So really we're going to discuss z-scores because it's just one of the most basic and I guess widely used in certain instances. It's not that widely used in psychological research, and I'll explain that in just a little bit of why it is, but not as much. So this is really wordy. It's not necessarily even my favorite definition. I would almost just want to pay attention largely to right here that it's a standard score. It's a standardized score. But the next part is true as well. It does tell you how far away a score is from the mean in units of standard deviation. So this whole sentence here, this whole definition is really good. Okay, so I would, I'm highlighting it. I would have you guys highlight it also and remember that. Okay, so a z-score is a standardized score, and it's a way for us to see how far away an individual score is from the mean. Okay, so we talked about scores deviating from the mean when we talked about standard deviations. So this is using standard deviation and then going back and looking at how far each person is from that mean. Okay, so it's a way for us to standardize data or some sort of empirical research. So here it says it's the difference between the raw score and the means of the distribution divided by the standard deviation. So there it just tells you this. Okay, it tells you the formula in words. It's the difference between a raw score, this is our raw score right here, and the mean, okay, of the distribution divided by the standard deviation. Okay, so that next sentence is just in words telling you what the formula is. Okay. So let's see, I'm gonna bring this up real quick just so I can see y'all's faces. Okay.
Wait, the kind of like the one that looks like a U, is that
Yes.
mean or is that the raw score?
Good question. So that is the mean. This formula right here is for population.
Population, okay.
Okay. And so if you remember back to chapter 3, when we had the mean, we had that guy with the sum of x divided by capital N. That was
Yeah.
the population mean, right? And then we'd have the sample mean, which was the sum of x divided by little n, right?
Yes.
So that thing, that UE looky thing, that's the population mean. And this one down here is the population standard deviation. Okay, we know it in the sample as S. Okay, so that one is population standard deviation. Okay. I'm gonna erase this over here real quick. We'll keep that one there. I don't know really how to draw that guy very well, that MEUE looky thing. Hopefully that works okay. For a sample, we can do z-scores with a sample as well. And it would be z equals the raw score. It's just the x, okay? Raw score, when we see an x all by itself, it's talking about a raw score, okay? So it would be the raw score minus the mean divided by the standard deviation, okay? So again, we have another formula here where different symbols depending on whether you're talking about population or sample, but it's essentially the same thing, okay? It's the raw score minus the mean divided by the standard deviation, okay? You will not have to worry about whether it's a population or a sample, okay? Because to calculate a z-score, this information has to be given to you, okay? Well, I mean, we know we can calculate the mean and we can calculate a standard deviation when we're given the data. If it's the population data and the population standard deviation and the population mean, that information has to be given to you. There's no way you could go calculate that on your own. Okay, so so you don't have to worry too much about that stuff. And let's go through some examples, and it'll make it a little bit easier. Okay, I promise. Real quick, let's just talk about. Well, okay, why do we do this? Z-scores are standardized data, like I said, or standardized scores, and they allow us to compare ourselves to people or things or, you know, events or whatever, because if we have that information, if we have that mean and we have that standard deviation, then we can compare ourselves to that data set and see where do I fall, where do I compare. Okay, z-scores in a roundabout way are given to parents when they take their kids and they get measured. Okay, they'll tell you he's in the 50th percentile for height, or he's in the 75th percentile for weight. We will learn percentile, and it's coming from z-scores. Okay, it's coming from standardized scores. Whenever you guys take standardized tests, SAT, ACT, GRE, things like that, those scores are based on a set of norms or means, right? A mean, and then they're going to compare your score to it and give you exactly where you compare or how you compare to everybody else. So z-scores are important, and they certainly have a place in certain realms of information that we might want to know, okay? And here, this last sentence in this first paragraph is saying that typically descriptive statistics, or what we talk about z-scores, they range from anywhere from a -3 to a +3, okay? It's quite rare to have z-scores beyond that, to have a -4 or a 4, okay? And I'll explain that in a little bit why. But really, those scores is something that we would call an outlier, okay? A really extreme score. And that can be a very, very small or a very, very large value, okay? Like the -4 or the +4. Okay, so when we compare them, they're really outside of the realm of what normal people are functioning in, okay? So an outlier is an extreme score, okay? Yes.
When would we be using like a z-score in what occasions? Because
Yeah.
compared to like a standard deviation when we're focusing on like population wise.
Yeah, really, okay, so z-scores are largely going to be used when they're trying to like norm data, or use a norm of some way to compare people to it, okay? So really out in the real world, where you see z-scores are, like I said, with kids or even adults too, when we're looking at height and weight. It's used in IQ, okay? And then in these big standardized tests where they're trying to norm data so that when you go in and take the test, they can see where you fall, all right? So obviously, like IQ would be the same, or yeah, go ahead.
Well, I'm confused on the idea of norm. Is it like saying like a range of what it's normal and what's abnormal?
Yes, that's okay. Yeah, that's exactly right. So they're trying to see how normal we are. We also have tests like that, like in psychology, we would have like some of the personality inventories, like a depression scale, an anxiety scale. They're going to be what we say as they're normed. Okay, there are some tests like you take on Facebook or Instagram or things like that. Those are not normed. Okay, those are just fun for you guys to do. A real test that has been standardized. Okay. Oh, look, I got an email about getting into my office. Okay, so that's good news. All right, so you want to like standardizing and norming, those two words could be used interchangeably. Okay, you know, IQ tests, personality inventories, some of these you know, big tests that we use for people to try and see if they're abnormal in some way. So yeah, and I guess that's why I say it's used. They are used quite a bit, but most research that we hear about is more along the lines of inferential statistics, where we're trying to figure out, you know, make a guess about a population. So sometimes z-scores don't really fit there. Okay, and that's when we learn about the t-tests. Okay. So let's see, let's go into this example right here. I wonder if can I pull it over? Oh, I can. Oh, okay, yeah, yay. All right, so here is an example, and we're going to use this. Well, let's look at it real quick. So it's saying raw scores and z-scores of selected students on 2 100-point tests in general psychology. Okay, so this is an example where this instructor, or it could be a she, is using the tests in their class and giving students z-scores so they can see where they fall in relation to other students in the class. Okay, you don't have to do stuff like this, and someone just seeing whether they're passing or failing is probably enough information for them. But you can look at this student right here. Chris scored a 76. They might be feeling pretty bad about themselves, right? I don't know, or happy, who knows? But these students down here might be really sad about their score, okay? But we always want to remember that the raw score is only as important as in relation to how everybody else is doing, right? So when we look down here, it's telling us the mean was 54. So the average was 54, okay? So this person, Robin, scored exactly average. Now we can see that Chris was quite a bit above average on this first test, okay? And Marty and Terry here are actually also above average, okay, for this first exam. So how they calculated these z-scores was using this information back here. They did z is equal to the raw score minus the mean divided by the standard deviation. And like I said, this information for the most part is always going to be given to you, okay? So if we wanted to, let's see, figure out how they got Chris's score right here, okay? So what they said was z is equal to the raw score minus the mean divided by the standard deviation, okay? Sorry, my handwriting is still not all that good on there, but I think it works. So I'm going to get out my calculator here, and 76 minus 54 equals 22. And 22 divided by 10 is going to give us the 2.2, just like they had right there, okay? 2.2, okay? Robin, right, their score, their z-score came to 0, and that's because she scored, I guess it's a she, I don't know, it could be a guy, I guess. Robin scored a 54, the mean was 54. Anytime 0 is in that equation, it's going to be 0, right? So the raw score is equal to the mean, therefore the z-score is 0, okay? That's always the case. If a raw score is equal to the mean, the z-score is going to be 0, okay? Let's see, we had some other people on here, but they were also above the mean. So I want to show you an example of where you would get a negative z-score, okay? So let's say, I don't know, Bobby went in and took the test, or we'll just say Bob, and Bob got a 47, okay? So let's see what Bob's z-score is. You take the raw score minus the mean divided by the standard deviation, okay? 47, let's see. All right, 47 minus 54, I get -7 divided by 10 is a -0.70, okay? calculating z-scores, I think you'll agree is pretty easy. Yeah, it's pretty simple. I like it because all the information is given to you, right? And it's a simple, very easy equation to do. The only thing you have to remember is to always have the raw score minus the mean. Okay,